17th International Physics Olympiad 1986 IPHO. I offer private tutoring for Physics Olympiad preparation. I currently have openings. There is a discount for group classes. Message me if interested. My email is fred1996@hotmail.com. Problem 1. Wave interference. A plane monochromatic light wave, wavelength lambda and frequency f, is incident normally on two identical narrow slits, separated by a distance d, as indicated in Figure 1.1. The light wave emerging at each slit is given, at a distance x in a direction theta at time t, by y equal a cosine 2 pi ft minus x over lambda, where the amplitude a is the same for both waves. Assume x is much larger than d. Question 1. Show that the two waves observed at an angle theta to a normal to the slits have a resultant amplitude a which can be obtained by adding two vectors, each having magnitude a, and each with an associated direction determined by the phase of the light wave. Verify geometrically, from the vector diagram, that a equal to a cosine theta, where beta equal pi over lambda d sine theta. Question 2. The double slit is replaced by a diffraction grating with n equally spaced slits. Adjacent slits being separated by a distance d. Use the vector method of adding amplitudes to show that the vector amplitudes, each of magnitude a, form a part of a regular polygon with vertices on a circle of radius are given by, are equal a over 2 sine beta. Deduce that the resultant amplitude is a sine n beta over sine beta, and obtain the resultant phase difference relative to that of the light from the slit at the edge of the grating. Question 3. Sketch, in the same graph, sine n beta and 1 over sine beta as a function of beta. On a separate graph show how the intensity of the resultant wave varies as a function of beta. Question 4. Determine the intensities of the principal intensity maxima. Question 5. Show that the number of principal maxima cannot exceed 2d over lambda plus 1. Question 6. Show that two wavelengths lambda and lambda plus delta lambda, where delta lambda much less than lambda, produce principal maxima with an angular separation given by delta theta equals n delta lambda over d cosine theta. Where n equals 0, 1, 2, etc. Calculate this angular separation for the sodium d lines for which lambda equals 589.0 nanometers, lambda plus delta lambda equals 589.6 nanometers, n equals 2, d equals 1.2 by 10 power negative 6 m.